All right, welcome to episode 2 of The Forge of Asgard. I'm Ryan Scissorhands, the author of Arms of Asgard, a Quake mod, and I've been working on a lightweight series on weapon modding for Quake. People in the community have pointed out that there are lots of video demos for making maps and modeling and all kinds of things out there, but not so much for modding. There are tutorials, but not so much something that shows you how to do it. So this is my attempt to help out, give back to the community, and take some questions I've been getting from the Discord channel about modding and actually demonstrating what I do and how I do it, and even just showing off my workflow. So last time, we turned the shotgun into a machine gun. We gave it less spread, made it fire more rapidly, consume less ammo, and fire fewer pellets. That ultimately made it a machine gun. Today, um, we're gonna make an interesting weapon that's going to spawn a boulder above the enemy's head, and it will drop on them and do some damage. This is a very untypical Quake weapon. This is not something I would actually recommend as a standalone weapon in Quake, but it forces me to tackle a couple of things that are really important for Quake weapon modding, in particular using the trace line function to trace a line from where you're aiming and detect if there's a monster there. And then we'll be using trace line for some other things for spawning the boulder as well. So, just to recap what I went over in the first episode, the source code that I'm using is just ID's original or vanilla code. Just because that's what I know best, and since this series is designed for just showing off a few things, I want to make it as easy for me as possible and make the barrier to entry as low as possible. Though I do recommend, if you're going to make a mod, consider other code bases. Copper in particular fixes a lot of the things that ID would have fixed in Quake if they had more time and weren't so burnt out, but it is otherwise a pretty pure Quake experience. And Arcane Dimensions, that has a really good dev kit. I don't know if there's a dev kit for the newest version, but a great code base. And it gives you access to a lot of things, and it means that mappers have access to a lot of things if they choose to make maps for your mod. The second thing, the compiler I use and also the IDE I use for actually editing the code is FTE QCCGUI, maintained by Spike. It is fantastic. And then the engine I'm using is also the FTE engine, also maintained by Spike. It's just my favorite. It makes things easier, and it has features that a lot of the other ones don't. So that is my engine of choice. Moving on from the assumptions. So just last time I kind of recapped how vanilla weapons work in the code. There is a central weapon attack method that is called constantly, basically. And from there, it says, okay, if you're attacking, what weapon do you have? And then that logic, based on each weapon, either triggers animation or attack function or both. And then they trigger each other. Usually it'll either trigger both or it'll trigger the animation, and then the animation will call the actual attack function. And then one of these two has to trigger the sound, check and consume ammo, and set the attack cooldown. For today, we're going to focus on just the attack function. I'm not concerned with animations, sounds, ammo, cooldown. Maybe cooldown, we'll maybe keep that in there, but I'm really going to be editing the attack function for this one. And the quote weapon I'm making, which is really more of a spell, is Summon Boulder. So what it's going to do is you aim, and if you're aiming at an enemy, it will spawn a boulder above their head, which will fall on them and do lots of damage. Again, the scope, we're only dealing with the attack method. And basically the steps are just check if there's an enemy, if you're aiming at an enemy. And that's where we'll use the trace line function. And if you are, we're going to spawn an object above the enemy. We're going to do it the easy way first, just for proof of concept. Then we're going to code in some object damage upon impact. And then lastly, we're going to redo this easy version of spawning the object above the enemy. So just a high level, the easy way is we just go so many units up, and that's where the projectile is. The smart way to do it is trace a line from the enemy upward a certain amount. So if there is something above their head, we don't want to spawn it past the ceiling or into the ceiling. By doing a trace line up, we can say, okay, if it hits something, just spawn it there. Spawn it as high as you can above the thing, because the speed of the falling boulder will affect damage. So that's the plan. That's what we're going to tackle today. So to get started, I'm going to open up my GUI, go to my Quake Spasm folder, and I think I've been using Forge 0. Maybe Forge 1, because that... There we go. Doesn't seem right. Let me just check and see if this is, in fact, a machine gun. All right, it was Forge 0. Take 2. Okay, well, take 3. Oh yeah, Forge 0 is the newer one. Normally what I would do is I'd put the source file in the source folder. I clearly haven't set that up properly. I will do that again next time. Yes, so how I knew is when I opened up Forge 1, there were about half as many QC files, and that definitely wasn't right. So what we're going to do is we're going to go to weapons. We're going to look at weapon fire shotgun. And this is what we edited last time. This is where we turned it from a shotgun into a machine gun. You'll notice that it consumes fewer shells. Normally this would consume 1 shell per shot. It only fires 1 bullet here. Normally it fires more as a shotgun. And then elsewhere we edited the attack time. This time what we're going to use as our code base is we're going to overwrite the with weapon fire super shotgun method. So this is just the attack part. It just has nothing to do with animations. We're not going to touch that. We're going to keep the same sound for now just because it's easier. Now, first let's see what it's doing, see if any of this code is necessary. It defines a vector for direction. We'll probably be able to use that. This chunk of code just makes it so that if you only have 1 shell and you have the super shotgun, it does the regular shotgun's attack. We don't need that. Punch angle, that's the recoil, or the visual effect of the recoil. I just don't care for now, so we'll just remove that. We'll actually comment out the ammo consumption. And then none of this we need. We have basically triggering a sound, and we have defined that there will be a vector called dir for direction. Pretty easy. So from here, what we want to do is determine if we're aiming at a monster. So first what we're going to do is the direction, the vector, we're going to define it as where you're aiming, which normally is v_forward, which is a global variable. But in order for that to work, we need to define what that variable is. So there's a method called makeVectors. So it's a method called makeVectors, and it takes in a vector angle. And what it does is you say, okay, here's the direction I'm aiming. And then it says, I'm going to set v_forward, v_right, and v_up as relative vectors to whatever angle you send me. So what this basically does is make vectors self.vangle. In this case, this self, the entity calling this method, is the player. So V angle is an angle of the viewing angle for the player. So this basically says, based on the direction this self is aiming, give me some vectors that I can use, V forward, V up, V right, and that just calculates it for us. So now at this point, we've done that call. It says the global variable V underline forward, and then this now says, okay, the direction, we're just going to set to V underline forward. This isn't necessary, but I like to do that just in case we need to modify this, because you don't want to actually modify V underscore forward. You want to modify your local vector here, the one we've defined in this function. All right, so the key to this is the traceline function. One of the things I really like about FTEQCCGUI is if there is a well-defined method and I put it in there and start the brackets in which I put the arguments I'm going to pass, it actually gives me the definition here, vector v1, vector v2. So this is always, when you're trying to trace a line, you need to know the origin and ultimately the destination you're aiming for, and it's going to trace a line along the shortest straight line path between those two vectors. Float monsters is whether or not you want it to ignore monsters, because in some cases you actually want things to go through monsters, but in others you want it to hit the monster itself. Entity for ent, in this case, is self. I think it's the entity that is calling this. I still don't actually know, but I've never put anything other than self, and it always seems to work. So here's what we want to do. Ultimately, we want to make a line from your gun to straight ahead of the gun. At this point, this dir is equal to the direction forward. What I'm going to do is I'm going to change this because we want it to be positional and directional, kind of. So I want dir to be, I'll show you what I'm doing here. This will make more sense. We want to calculate the origin from where the player is. So if I were to just say dir equals self.origin, it would be exactly where the center of the player is, if I would comment this out. Where I actually want I'm doing something wrong here. I'm going to split this up. We need two vectors. We need origin and direction. Pardon me for just kind of deleting things. So the origin is your origin, but we're going to go, we want it to be where your gun is. So we're going to go up, I think I typically do 12 units. So what this is a vector in the land of Quake in Quake units, and it's X, Y, Z, 3 integers. I think they can be floats. I've just never really messed with that. 3 integers, X, Y, Z coordinates in between single quote brackets. I usually don't mess with X, Y because those are usually relative to the player and you have to do all kinds of stuff. But like up is always up and down is always down. So 12 units is 12 units up. If I were to make this negative 12, it would be origin or org would be the player's origin and then 12 units down from there. But I want it up. And then the other thing is I want it to be slightly ahead of the player so that the origin doesn't start within the player's hitbox. All right, so the origin for this line is going to be where you are and a little bit up and a little bit in the direction you're facing. Again, that's because v underline forward will be defined in the global variable once we make the make vectors call. Direction is going to be ahead of the origin. So the beauty is that we can just say it's origin plus v underline forward times, let's say 1,000 units. So it's a pretty long range weapon for a hit scan, in Quake that is. So we've got an origin, we've got a direction. Now we're trying to trace a line. So the arguments it needs right here, vector v1, vector v2, float no monsters, entity for ent. So start, vector 1 is origin. The second one is direction. Since we've already defined those, it's really simple. Float no monsters is whether we ignore monsters. We don't want to ignore monsters because we actually want to target the monster. The goal with this isn't something like lightning gun where you're just trying to do damage and you want it to pierce and whatnot. We actually want to know, am I aiming at a monster? So we'll set this to false, and then the entity that it's for is me. So what traceLine does is it traces the line, but it's going to define a few things, like some comments in here. Trace ent. If I make reference to this in the code now, that is the entity that was found by traceLine. That's another global variable that we get by calling traceLine. So traceEnt. So that equals the entity that it hits. Trace end position equals where the line stops. So if you wanted something to like create an explosion based on where you're aiming, trace end position would be very useful. Or if you want something to happen based on where that line ends, and it can be stopped by either like the world, like a wall, floor, ceiling, any brush in the map. And then depending on whether this is true or false, you can either go through and ignore monsters, or it can actually target them depending on what you want. Nice little toggle switch on this traceLine call. Now, I know a lot of people in their code bases have made like traceLine 2 that does some smarter things and whatnot. Let's just keep it vanilla for the purposes of this. So, main thing is, if you're targeting a monster, we want it to do something. If you're not targeting a monster, we don't want to do anything. So, the easy way to code this is if the trace entity that is returned can take damage. That would be the easiest way to do it because we're not really concerned with anything that doesn't take damage. So, now, if there is no trace entity, I believe it returns world, but the world can't take damage, so that case should be covered. Ultimately, we want to do, I don't want to put a ton of code in here. I actually just want to call a separate method. I want to modularize this. So basically, if you're aiming at something that can take damage, spawn Boulder. And what we want to do is we want to spawn it. We want to pass some information. We want to say, where do we spawn this? Well, we want to spawn it above the trace entity. And for attributing kills and damage and all of that, I want to know that I created this thing. Those are 2 bits of information that we need. Where am I spawning the boulder? Like, who's the victim? And who is doing the attack? Right now it's the player. Now, I haven't defined spawn boulder yet, but I know that basically I want to spawn a boulder above this guy on my behalf. This is a bit backwards to how some people would do it, but I like to build it where it's just like, I just want to spawn a boulder. So literally call it what you want it to be. Note what information is necessary to execute what you're aiming for, and then I'll go above there and define what that is. Spawn boulder. I always start by putting in my bracketry so that at least it'll compile even if it does nothing. And we're going to call them locally in this method, we're going to call them victim and attacker. So ultimately, when this is called here, it will pass the trace entity as the victim and self as the attacker. So now we know who to attribute damage to and where we're going to be spawning this. The other thing we can do at this point is this does nothing, but it's still testable. And I really like to test as I go. So main thing is I'm going to print just a message. I'm going to change the target takes damage. Just giving me a message that a little character or endline character. Just letting me know that this logic actually worked. So if I'm aiming at something that takes damage, say target takes damage, else bprint does not take damage. So at this point, I'm actually ready to test. I recommend doing it because if you have to debug a whole bunch of things, you have no idea where the problem is. Whereas if you do it iteratively, I at least know that what's going on here. I can test if this trace line works. I can see if it is actually the right flag here, because sometimes I get the float no monsters wrong, and I mean true and I put false or whatnot. I'm prone to that mistake, and I know this. So let's test it out before I go any further. It compiled on first try. That is what you want when you are streaming. Sod. Spasm. I guess I haven't selected the engine or not. Properly saved that. All right, here we go. All right, machine gun's still working. I don't have that, so I'm going to impulse 9. But if you're doing a weapon mod, one of the best things you can ever do is bind a button to impulse 9 so that you can hit one button and then even put that into your auto exec to make sure that you can test your weapons very easily without having to type it every time. Interesting. It's not doing what I expected. Oh. Let me make sure that this is putting the file to the appropriate place. Didn't seem to have problems last stream, so I'm not sure why it would be struggling. It definitely took me a while to get used to the folder structure and how to best set up my my file and folder system with this compiler. But everything looks good here. I'm going to make sure that my progs.dat file that it's outputting is proper. Okay, I'm going to close this and reopen it. I just made some changes to the progs.source file. I really don't understand why I had to do that again. Huh. Not great. It's not actually using this code. Let's just trace things back and see what's going on here. See what calls this. This is what I'm expecting it to call. I'm going to do a little print. It's doing this at least. And if it doesn't start printing when I fire the super shotgun, I know it is not using my code, and I've got some sort of issue with where my file is going. All right. So let's just see what my options are. Forge 0. I'm just going to take a look in my Quake directory and see where that progs.dat file is actually ending up. So what I've done is in my 40 folder, I've moved everything into a source folder, which is really what I should have done here. I'm going to double check the progs. Yep. So this says that it's going to dump it into the parent folder into a file called progs.dat. And then this is the list of the QC files that it needs to compile. Also the order in which they compile, which can matter. All right, so now that I've done that, I'm just going to attempt this again. Sorry, this is not the smoothest this has ever gone, but honestly, like this is part of the frustrations of modding for Quake is just getting your like folder and your compiler working the way you want. And let's just make sure the changes we made are in this code base. So here for Fire Super Shotgun. Yep, this is my code. See if we can get it to print anything. Let's see what we got for options. 40. Oh, all right. Yeah, it was a folder problem and not a code problem. Important thing to note, because there are so many times that, you know, I get frustrated trying to debug something and it's not doing anything or it doesn't seem to be making changes that I'm expecting. The easy solution is just like hey, it's doing this, and see if you are able to make changes to the code that's being run. If you aren't, it's not a mod problem. It's a folder or a directory or the progs isn't going to the right place problem. So as much as wasn't happy to have that on stream, at the same time, it's good to know what to do. There have been a couple times where I've run into like crippling problems with my mod and then asked some questions in the forum and someone's like, oh, you probably did this. I'm like, oh yeah, I have a rogue pack file that's overriding a bunch of stuff. I don't know where it came from. I delete the file and everything works fine. So such is life modding. Well, such is life coding, really. All right, so right now it says it's doing this at least and then does not take damage. So let's see what happens if I actually aim at a monster. Target takes damage. Awesome. Test passed. I'm going to remove that other message. One of the things that someone brought to my attention, which is like super rudimentary, but I didn't know, is that there's like a dprint, which is a developer print thing that will only print if a certain setting is on. So that way you can hide your secret debugging messages and the player never sees them, or you don't have to delete them later. I haven't used that or looked into it. I plan to soon. I didn't today, so I'm just using bprints. But ultimately, this works. We know that if I'm aiming at a thing, it does this text, and if I'm not aiming at a thing, it does this text. What I am going to continue to do in here, and this is for the player, I'm going to center print why it's not going to work when it doesn't. And when you are aiming, it's going to spawn Boulder. Now, right now, that does nothing. What I want it to do is spawn a Boulder above their heads. So first thing we're going to do is define that there's an entity Boulder. The first thing you always have to do for an entity is to spawn it. That I believe puts it in memory, or at least defines that, yes, this is a thing we can edit and do things to, and then from there you can define its various properties. So the first thing I always like to do is the ownership, and the Boulder owner is ultimately the attacker. That way we can make sure we don't do damage to the attacker, and we can give credit to any kills that the Boulder causes. to the actual attacker. There would be nothing worse in Quake than a weapon that doesn't give you credit when you kill people. We also have to define some of its physics. So there's a property called move type. I'm going to use move type toss. There's a whole bunch of different ones. Most common one for projectiles is fly missile or bounce. Actually, I'm going to go bounce because bounce is the same as grenades. Toss is slightly different. I forget um, the there's some minor but important distinctions between the two. One of the other things I'm going to bring up on stream here is the Quake C reference manual. Just briefly here, this is the best resource on the internet that I know of for just like general Quake C questions. It's a PDF by David Darkgoo, I guess, and it has everything you need and is searchable. So if I go move type underscore, it goes to the move types here. Move type non equals value 0. That's things that don't move. There's move type walk, step, fly, toss, push, no clip missile, bounce, bounce missile, which is not supported in vanilla, strangely enough. But we want it to fall. So we either go bounce or toss. I don't know the difference, but we'll go bounce because that's what grenades use. Move type bounce. And then, of course, you need to define what kind of solid it is and how it interacts. So, same sort of thing. You go to this manual, you search it up, solid not, things that are not solid. Trigger, B-box, slide box, BSP, all kinds of stuff. Like missiles and grenades are always solid B-box. So that's what I'm going to use, but certainly there's other options depending on what you're trying to achieve. So I know who owns it. I know how it's going to move. I know how it's going to interact with other objects. We, of course, have to define what happens when it touches things. We have to define what the model is. And we have to define its origin. So there's a set of methods that you want to use when you set the origin to something. In theory, you could go boulder.origin equals something, but it's flaky and not the proper way to do things. The proper way to do it is to use a couple of methods: set origin, set model, and set size for like defining the physics. So I always kind of have those together. So I'm just going to stub those out here. So we need to set the origin, which we don't do first. I shouldn't do that. You define the size and the origin. Sorry, the size and the model, and then the origin is, I believe, the conventional way of doing that. Set model, and again, when I bring that up, it says entity E. Well, we want to set the model of Boulder, and then string M is the file path to the model file. So we'll go prog slash boulder.model. Set size. Again, brings up what it needs for arguments: entity E, vector minimum, vector maximum. So entity is Boulder, and we're just going to use two blank vectors, basically 0, 0, 0. Also, the coordinates of the center of any map is 0, 0, 0, and everything is measured from there. And the last one is set origin of Boulder. And for now, we're going to do it the easy way. We're going to make it the victim's origin. And 100 above it. So that's 0, 0, 100. 100 units above the origin. There's some other stuff I could do here to make it the origin plus the height of its hitbox. We're going to skip it for now. This is the easy way. Just 100 units above it. If it's in the ceiling, that's where the boulder is. That's how it works. That should be easy enough to test. One of the things I like to do whenever I put in a model that I have not pre-cached is put a little comment to remember to pre-cache this. Some engines can handle not pre-caching things, others don't. FTE is very forgiving, but then if you develop for FTE and you go to run it in Quake Spasm, it's like, hey, you didn't pre-cache anything. Nice little reminder, though. I'll get to that later. And the other thing we can do here is if I don't have the model ready, but I just want to test my code, you can use any sort of model that's from the game itself. So funny thing I tend to do is just throw a shambler in because it's hard to miss because it's so big. So we're going to drop a shambler on people's heads. The last few things to define for this boulder is what happens when it touches things, which is we want it to damage, and then how does it delete itself. The easiest way to do this is self.touch equals some sort of function. Convention is t underscore boulder touch. T underscore is just the prefix that is typically used for when things touch. I'm just going to follow that convention because it's easier and keeps my code a little easier, more searchable. All right, so I have to find what happens when it touches. And then for deletion, if you set a time for it to next think and what it's supposed to think, it waits that amount of time and then it does the appropriate method. So self.nextThink equals time plus 3. So time is always whatever time it is when this is called. So time kind of equals now. Units are in seconds, so this means that this object is going to think something in 3 seconds. 3 seconds from when spawn boulder is called. But now I have to tell it what it is thinking. And I'm going to make it t underscore boulder touch. Nope, I'm not. Sorry. I want to remove it after 3 seconds. Oh, my typing is bad. So I think equals sub remove. So ultimately, if it collides with something, it's going to call this. And then regardless, in 3 seconds, it's going to call sub remove, which when an entity calls it, it just deletes that entity. So I think we have everything we need to at least make shamblers appear above people and fall to the ground. With one exception, I need to have some body to the boulder touch method, even if it does nothing. One of the things I will do, though, is just have a print thing here to show that there is something working. And that I know that this method is being called. If for some reason it had the wrong kind of solid, it might not touch, and then this message wouldn't happen. So I am testing whether or not it's able to actually connect to things. My error here in compiling was it said center print. All I had was a string. What you'll notice when I bring this up, center print. Oh, it's not bringing it up. It actually needs two arguments passed. One is the entity to print in the center of, which in this case is the player, and the string. bprint just needs a string because it prints it to all clients. So forgot about that extra argument. It warned me cannot cast from string to entity because I was throwing in a string of letters. It's like, no, man, I need to know who to print this for and then what to print. Now that that's fixed, it should compile. So it's printing no target when I'm not aiming at anything. Yep, we have a falling shambler. Okay, falling shambler, not particularly exciting. Now here's what we're going to do. We're going to make the falling shambler do damage. Whenever something touches, there is an implicit entity, which is the entity with which it is making contact, called other. So one of the things that doesn't make sense unless you know that this is the case is that you can always just call other in a touch function. I actually don't know how that works from a code perspective. I just know that it works. So again, this is another one. If the other thing can take damage, then let's do some damage to it. This is also where you trigger impact sounds. And we're just going to do some damage here. So T underscore damage. So you need the entity, the target, the entity that is the inflictor, entity that is the attacker, and then how much damage to do. If you're ever confused about the inflictor and the attacker, the inflictor is like the projectile itself, but the attacker is who gets credit for it. It's the way I think of it. So in this case, for projectiles, entity inflictor is almost always self, and attacker is usually self.owner. That was the main reason that down here we defined the boulder's owner, so that we can give proper credit. So again, if I do this, brings them up. Target, inflictor, attacker, damage. And those have to be in that order. So the target is other, the thing we're touching. The inflictor is the boulder itself. Since this is the boulder calling the touch function, just throw self in there. The attacker is self.owner, which is the originating player, and the damage is, let's just say, I mean, it's a boulder. Let's do 100 damage impact. Other things you could do down the line is make this variable. You can add some random stuff. In fact, I'll just quickly show how to do that. Let's make it 80 plus random times 40. So random function always returns a random value between 0 and 1. And then from there you can scale it. But it is always a positive number between those two values. So ultimately, at the low end, if random is 0, this time 0 times 40 is 0, and you do 80 damage. The high end, if random is, say, 1, this would be 40, it would be 120 damage. So this will ultimately be like rolling some sort of damage value of linear distribution between 80 and 120. This is going to be insane damage because if it bounces on things, it's just going to keep hitting them. There's other ways that you could handle this. You could give the boulder so much damage, and then every time it hits, it gives off some of that damage and gets rid of it. And if it runs out of damage, it does nothing. For now, let's make it an unmitigated disaster of too much damage and see what happens. You'll notice I test on E1, M1 like always. Doesn't appear to be killing anyone. Well, we had a crash. Perfect. Ooh, wow, that crashed so hard. Well, that's unfortunate. Let's see what's going on here. That's where it crashed. Oh, jeez. I set self.touch, self.nextThink, and self.think when it should be boulders touch, nextThink, and think properties. So this was trying to delete the player in 3 seconds. Not ideal. That's why the shamblers weren't going away. I have made that exact problem so many times, or putting in self when it should be self.owner, and I've got a really long chain of projectiles and ownership and whatnot, especially when you have an entity that spawns an entity that spawns an entity, but that needs to be owned by the player. All right. Take 2 on this. I'm going to edit my auto executable file to always go to skill 3. Always go to E1M1 because there's monsters right there. All right, well, that's ridiculous. But like, so many of my good weapons actually started out as something silly as a result of a bug. I'm like, oh wow, what is that doing? How can I use that? The last thing I'm gonna do here before I wrap up the demo, I'm going to borrow an asset from Arcane Dimensions. So Arcane Dimensions is kind of the most epic Quake mod of all time. Fantasy themed, has a ton of code. It incorporates monsters that have been made by the community and other projects and compiled it into one so that people could do mapping and use any monsters they want from that. It is just an absolute work of art. And they release it on an open license that, you know, anyone can use it, anyone can use the assets, but you also have to make your project open source and whatnot. So, you know, I mean, there's terms, but they're very, very reasonable terms. And so, given their open nature and given that this is a project really for the community, I'm going to try and find the Boulder um, model. Sorry, I'll just be a second. I'm in my other window because I don't really want to expose my entire hard drive's file directory on a stream. Now I have also made a modification to the Boulder, and I know where that is. So I'm probably just going to use that, but I definitely cannot take credit for it. All right, I'm just going to open up in a model viewer this rock.mdl. So this comes from our Arcane Dimensions. I forget what it actually is used, like what monster uses. I think it's a projectile for, I want to say the Minotaur kind of dude. Oh, I don't even have a procs folder. I'll just save it in the folder for now. And I'll go and fix that. And it's called rock.mdl. All right, so now I just have to, I'm going to actually rename it to Boulder to make it line up with what I'm calling it in the code. Good rule of thumb is to be consistent. And I know it's very easy, especially if you're working on something that's kind of a work in progress, that you change names. It's not always worth going back and changing it, but if it's something you're planning to release, it's a good idea. And I still have to do some of that for Arms of Asgard before I do a full release of the source code, because some of it is embarrassingly inconsistent. So back to the code, I need to replace shambler.model with boulder.model. And then the other thing is I need to pre-cache it as per my comments. So I'm going to see where I might slip that in. Okay, perfect. Yeah, let's go to the where weapons pre-cache sounds and models. Oh, this is slightly different from the source code that I usually use, which has a bunch of sounds and models. I'll probably end up putting it in player.qc, I think is where all that stuff is. Very strange, though, that there's no models pre-cached in weapons, or at least in the code base I'm used to using. Sounds are in world. All right, world, this is where it's pre-caching models for player projectiles, so I will follow that convention here. This stuff is boring but important. You have to make sure it loads it into memory. And that should, in theory, work. And there we have it. Now, there's other things we could do here at this point. We could make it so that it does area damage on impact. We could make it explode and disappear on impact. The two other changes I would do to iterate on this, now that we've proven the concept and gotten things working, would be a couple things. One would be making the position of the boulder vary and make sure that it doesn't spawn inside a wall or inside, I guess it would be a ceiling or a platform or something. So the way we would do that is, let's get past it. With Fire Super Shotgun, here we go. Oh, and by the way, I definitely put this in the wrong place. This should be all underneath our Weapon Fire Super Shotgun little header here because it's all related to that, and I had it with a shotgun. Copy, paste, clean up your code. So at this point here, we're setting the origin to just 100 units above the victim. The other way we could do this is trace a line from the victim up and then spawn it wherever that ends. So we will do that with, again, the traceLine function. And I'm going to go victim origin plus, there will be bugs no matter what I put in here unless I do something really smart with this. And I'm going to go, I should be doing this max Z. I think. So that should be the vertical component of how big their hitbox is, kind of. Now, and this is going to be messy. Here's what I'm going to do. I'm going to define another vector, another origin again. Here's what I'm going to do, just to keep my code a little cleaner. I'm going to define origin as the victim's origin plus their Z value. Because what I'm going to do when I trace line, I'm going to go origin as the first one, cleaner when I'm calling trace line, and then origin plus I'm thinking 250, I think 200 units above them, or up to 200 units above them. Sorry, I'm not done. I have a couple more things to do. Float no monsters is true. I want to ignore monsters, and it is for the boulder's owner, because we're in the context of this is being spawn boulder is being called by this, which is being called by the player. I guess it isn't self.owner, it's just self. There we go. So we're tracing the line up at this stage, and then we're going to set the origin to the end position of that trace line. So this should ensure that it doesn't get spawned in a ceiling or something like that. 200 might be too high because at the rate that it falls, it might not hit a lot of people, but I mean, I'm not making this to be a perfectly balanced weapon. Hmm. It's maxes? Maxes Z. So ultimately what this is, just for some context, every entity has some maximum and minimum left, right, whatnot, and that defines their hitbox. By putting this underscore Z, it says just the Z component of the vector maxes. I'm not 100% certain this is going to work, but we'll see what happens. Definitely failing. Implicit conversion from vector to float. Vector origin, so this vector equals victim.origin plus so if this is just a number, so it's saying this is just a float, not a vector. So I think what I need to do is actually take this number times a vector to make it a vector. So ultimately, if this is 10, this will then be 10 units up. If this is 100, this will be 100 units up. So this is an easy way to convert a number to a direction, or number to a vector, especially easy with height. If it were X and Y, it'd be more complicated, but again, up is always up. So it should be better than what I had before. And we now have a boulder spawner. This, again, was more proof of concept than anything else. I think the other thing you could do from there is instead of making it so you have to aim at people, it could be something that checks in a radius around you for enemies and spawns rocks above all their heads. I think this doesn't make a ton of sense as a weapon, but again, weapons are the ones that deal with all of the vector math and all of the stuff that that interests me, at least. That might even make a more interesting monster attack, that it's constantly spawning things above the player and they have to dodge them. At some point, I had an idea for a weapon attack from an enemy that would cause two projectiles to the left and right of the player to then attack the player, so that they couldn't just strafe to dodge it. They'd have to actually pay attention and move either forward or back. I'll probably do something like that in another session, but I want to wrap this up today and just go over some of the highlights of what we've done. Main thing is we discussed some make vectors and how that works, and how you use the player's view angle in order to define your forward, up, and right components relative to where they're facing. We did two versions of traceline, both with not ignoring monsters, which is false, and ignoring monsters, which is true. We looked at only damaging things that can take damage. Trust me, it'll crash if you try to do damage to like the world or a torch, so this is very important. We created a new function that takes in a couple of arguments, being the victim and the attacker, and then we leveraged that to do damage. And then we made a touch function for the projectile itself. So thanks for joining me here at the Forge of Asgard. And I think next session I'm probably going to dig into some of the weapons, or at least one of the weapons in Arms of Asgard, and go through how my code achieves some of that. I'm really excited to go through the gauntlets at some point, but I think I need to clean up my code before that is a less embarrassing scenario. Anyway, thanks for joining me here on Forge of Asgard, and see you next time.